So some of the words you guys came up with our plus sign. We had things like some, and we had positive. And I'm going to make this do this so I can actually get in here and make that a little bigger. And we had add, and we had plus, and addition. I'm gonna put another one on here, combine. Because I could combine 2 apples and 4 apples into a pile of 6 apples. So plus, some, positive, add, those are all great words with that. Let's see, the next one down we had our minus, which is on the screen over here. Things like subtract, fewer, oh, that's a good one. Minus, take away, let's see, negative. The difference, that's great. Those are fantastic. You guys did great on that. So on our little star here, good. A lot of us caught that that is in fact multiplication. Multiply or times. This one also could be the product. The product of 5 and 3 is 15. For the division one, oh, I like that. I've got division, opposite of multiplication. Fantastic. So we got division, divide. I'm going to put another word over here. So this is our quotient. The quotient of, that's a good one. I see someone put square root on there. It's not quite the square root. Square root would have the little kind of check mark house. And we've got our equals, solves to, the answer, on here. One that a lot of people don't think of, but we use almost every time we talk about it. Like the product of 5 and 3 is 15. What word in there meant equals? Is. It is 15. It equals 15. Okay, and then our last one here, we've got PEMDAS, distribute, multiplication times multiply, parentheses times PEMDAS a lot. So this is our parentheses, which I'm probably spelling wrong. This will show up when we're looking at things in words, a lot of times with the group. We'll say the group, or we'll say something like and then. So if we add 2 and 3 and then times by 5, so 2 plus 3 parentheses times 5, and then means we're gonna group it together. Okay. So what you can, I was like, if you can't tell from this, what we're going to start working on is taking words into math and math into words. So being able to kind of translate words and mathiness. I like that. Okay, so what I'm going to do, or what we're going to do is we're going to talk through this first before I jump ahead of myself into what we're doing, because I get very excited when we have things. Yes. Yeah, I can write you past now. Just because they have very limited times. We're allowed to write passes, especially in 7th period. So we're going to look at these, and we're just going to kind of talk these through. It's kind of the opposite of what we just did. The first cabinet.
First catch of the year.
Not surprised. All right. So what we're going to do is we're going to kind of practice. We're going to take these sentences and we're going to put them as expressions. We're going to put them into math. So we've got 3 times a number minus 7. How could I write this 3 times the number minus 7? Yeah, 3 times some number. If I don't know what it is, what do we use? A variable. I don't care if it's X, N, smiley face, happy face, heart, whatever. I don't care. It's a variable. So I'm going to put X just because that's the one we're most comfortable with. But I genuinely do not care which variable you choose. So 3 times some number minus 7. Minus 7. So then we've got a number minus 7, then multiplied by 3. So what are we going to do?
3 parentheses, that's minus 7.
Yeah. So we're going to do a number minus 7, so some number minus 7, and then, so it means I need to do my subtraction first, times by 3. And I don't care if we put it at the end or put it at the front. The best math grammar does have it out in front, but I genuinely do not care. So a shirt costs C dollars. So this time I tell you what variable to use. C dollars, and is on sale for 60% off. Or 60% of the cost. How could I find out what I'm going to spend? If I know the shirt originally costs C. How do I find 60%? This is math we should be able to do because we see this in stores all the time. So let's be able to make it. How can I find out what 60% is? You could divide, but that's going to be the hard way. Times 0.6. 60% as a decimal. Remember, scooch it twice for percent. C times 0.6. So we want to know the total number of hours worked when someone works 7 hours each day. If we don't know how many days it is, but we know they work 7 hours a day. They work for some number of days and they work 7 hours each day. What do we do with those two values? Not quite divide them, but I love that instinct. We're going to multiply them. I know they work 7 hours every day. So if they work 1 day, they earn 7 hours. If they work 2 days, they work 14 hours. If they work 3 days, they work 21 hours. What we're doing is we're taking that number of days times the 7 hours per day. All right. The last one before we get into what our activity is today. You guys okay? Okay, I was just making sure someone wasn't knocking. All right, so if you are working some number of hours and you get $7.25 an hour, how can we figure out how much you're going to get paid? Yeah. 7.25 times however many hours you're going to work. That'll tell me how much your paycheck should be. That 2 looks weird. I'm going to rewrite that 2. So we're going to be working on kind of translating words into math. Okay. And the kind of table-y looking thing you guys have on page 10 is kind of a workspace for you. It's designed very bizarrely, just saying, for the activity that we're doing. I don't have anything in particular I need you to write in those boxes. It's just space for you to be able to work. So what we're going to do is we're going to start with this set of green, like, cards. And what it does is it makes a circle, but this is so you can kind of see how it goes, because the set we're working with is really like 16 cards, and so we can get the mechanics down. I want you to look. So make sure that you have 4 cards in the green. You guys are going to work together. If you want to work with them, that's totally fine. We'll probably get back and when you guys just make up something, that'll work. So what you're going to do is you're going to see it has different sentences, like different math sentences on there. And one says the product of 7 and a number. One says 1/2 of the opposite of 8. It's got a sentence kind of at the bottom. And what you're going to do is you are going to find the card that has the matching expression. It's read as an I have, who has, but honestly making it work out loud is really annoying unless you are able to do all of this in your head. Okay, so we're going to work on it another way. So when we say 1/2 of the opposite of 8, what does that mean? 1/2 of the opposite of 8. Yeah, 1/2 of -8, which would be what? -4. So 1/2 of the opposite of 8, this one has -4. So then we read this sentence, the difference of a number and 5. And we look on these other 2 cards and we see which one goes there. It's going to make like a circle. This only has 4, so it's really kind of making a square. Okay, but I want you to do those 4 so that we can kind of get a feel for the way this system sets up. Because the other ones we have are more and longer. All right, so work with the people at your table. Work with the people at your table to get those to match up. Missing one of mine. White. Okay. He's got the cards in here. All right. Once you guys figure out the two ones in their order, and you use the bigger set. So you guys can work on that. It's a lot of cards, so if you want to look at them, that'll work well. So yeah, so you're gonna figure out the order for all 4 of these. So put them in. So like, so the difference of a number and 5, one of these has that expression. Okay, and so kind of line them up to make a column. And then I have one more set of cards over here. No, you're making a column. The game part of this doesn't work, and it doesn't really make sense because there's just too many 11 cards. There's too many, and it would take one set crystal to do it all. To listen really good, and paying attention, and it just doesn't flow well. The way they do it only works for grown-ups who care about this stuff. It's not really y'all. So what you're gonna do is you're just gonna make a tower. You're gonna make a tower. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually. So you'll pick one to start, and it should move back around eventually Okay? So all the cards in your set should connect together. Got it? Kind of see how it works? Yeah, that's what it is, because I didn't want us to have to do all of that figuring out with a set this big.
I see this is
Yeah, yeah, that's good. Okay, so it's the same vibe, but there's just a lot more. Okay, so that's why we started with the little one, is we get the flow and the mechanics of it before we work on that. So work on trying to get those matched up.
Wait, we match these up now?
The white, they don't mix with the green, so the, all of the other cards. So you guys can do this one. It's the same mechanics, the same structure, but it's just not more cards. So it's easier to figure this out when it was only 4. Say again. Oh, and? I was expecting to the difference of 4 times the number and 8 times the same number. Yeah, I'm with you on that one. That totally tracks. Because we have a lot of activities like this that we do, and I lose them everywhere. Thank you. So, no, not really on that one. Okay, so let me find the. Yeah, a lot of the words are really, really similar. So. Okay, I see it. So right here it says the difference of a number and 7. So the difference is we're gonna subtract, right? Some number that I don't know and 7. So this is the difference of a number and 7. This is x minus 7. Those two things mean the same thing. So this leads to this one. And then you can take this, 6 subtracted, that's our one, from the opposite of the sum of 3 times the number of 5. So that's a big one. That's a really, really hard one. Okay. And it might be that we need to write it down, 6 subtracted from the opposite, and like try and like take the pieces in little bits at a time and write it down into numbers. So that way you have that paper there so you can find it, because we're gonna have to simplify it. Some of these are real weird. So see if you can get it down into numbers. Yeah, some of these are really complex. But you have all that space on page 10 if you need space to write it down so that you can kind of simplify it, because some of them are like real simplified from the words that it has. Yes, dear. Okay. So, let me grab a thing real quick. I'm not abandoning you. Just grabbing my. So let's start with how could I write that? Just as it is right now. What does it say? What does it mean as an expression? Subtract 10 from a number. How do I write subtract 10 from a number? Is it 10x?
No.
If I'm subtracting 10 from a number.
So like, pick a number and then subtract it by 10.
Yeah, but if we.
For the variable.
Oh, so we use a variable. So x minus 10, right? So that's the first thing, subtract 10 from a number.
And
And then multiply the result by 3. So I need the result of this. So how can I say I need the result of this? Parentheses. And times 3. That's 3 6. Okay, so that's our expression. And that doesn't exist anywhere. But could we simplify this? Yeah. I was gonna say.
Oh,
I thought
okay,
you
so
got it.
yeah,
I
this
thought
is
you got
that
it.
one.
Yeah. There you go.
Okay.
So that's what that space is for. Is if we need space to do that kind of work. Okay. It's like I'm not gonna be looking at anything out of place, but it gives you a space and it's separated, so your thoughts can stay separated. Okay. So yeah, some of them are really weird. Jeez, that one's really tight.
Oh, this is twice.
6.
Difference is subtracting, right?
Yeah.
Uh-huh.
Yeah. That seems
doing this as an out loud game was just too much. Too much. Sometimes.
I feel like it could be simpler if there was less cards.
Yeah. But I'm like, then I have to rewrite the whole game.
Yeah.
And I was like,
Oh, we're just gonna try it this way, and we'll see if I just need to completely revamp it for next year.
and I'm just like, this is a hot mess out loud. I've tried it twice. Like, no, we're not doing it.
See, we have this game of culinary, it's like this.
Yeah.
More simple.
Yeah, this is a
I'd
lot.
like to do like a simple game and actually be a little fun, because they make it hard.
They make it hard and weird. Yeah.
If they worded it differently,
Yeah.
it would be easier. You got different times and the 8.
How are we feeling on it?
Right? Because that's why those are often is say and 8.
Uh-huh.
Because like just had half the difference of 4 times the number. Okay.
Mm-hmm.
So we say and.
Half the difference of 4 times. So 4 times would be 2 times, right? And a number x plus 8. So what?
Start from the back end and work your way forward sometimes. Sometimes that makes it easier.
And
So, 4 times the number and 8. Would be how I read it. Yeah, it's weird. It's weird. It's weird.
Plus 4.
Oh, wait, we didn't find out.
And my favorite thing is they don't give me the answers.
Add 10 to 3 times. 2x.
Oh. I figured out what they meant. That one, half the difference of 4 times the number. Yeah.
So we were right about the 2
The only thing I would say is difference. It's half of the difference of 4 times the number and 8. So the difference of 4x